Hello everyone, and welcome back to the channel. I'm so glad to see you here today. If you're new to this channel, please take a moment to subscribe. Click that subscribe button and hit the notification bell so you do not miss any of our upcoming lessons. If you find this video helpful, please give it a like. It really helps us to reach more students who need this kind of support. Also, I want to hear from you. If you have any problems or topics you're struggling with, please comment down below. I read every single comment. And for those of you who have personal questions or need one-on-one help, I will put my WhatsApp line below the video in the description box. Feel free to message me there. I am here to help you succeed. Today we are going to learn about a topic called binary operations. This is for further mathematics or additional mathematics, suitable for SHS 1 and SHS 2 students. Now, I know that when you hear the word operations or mathematics, you might feel a little nervous, especially if you feel you're weak in math. But I want you to relax. We are going to take this very slowly. We are not going to rush. We will break everything down into small, easy pieces. By the end of this video, you will understand exactly how to handle these problems. Let us look at what we want to achieve by the end of this lesson. These are our learning objectives. By the time we finish, you should be able to define what a binary operation is. You will learn how to identify the set it works on. You will be able to perform calculations using special symbols like star or circle cross. You will learn how to test for properties like closure, commutativity, associativity, and distributivity. We will spend a lot of time on determining the identity element and the inverse element. And finally, you will learn how to solve equations involving these operations. Let us start with the introduction. What is a binary operation? The word binary means two, like a bicycle has two wheels. A binary operation is a rule that combines two elements from a given set to produce another element within the same set. You are already familiar with binary operations. Addition is a binary operation. When you add two numbers, you get a third number. Subtraction is a binary operation. Multiplication is a binary operation. In further mathematics, we define custom operations using special symbols. You might see a star symbol, or a circle with a cross inside, or a circle with a plus inside, or even a triangle. Do not let these symbols scare you. They are just rules. Let us look at the notation. If star is a binary operation on a set S, then for any letter A and letter B in that set, a star B equals some expression involving A and B. Here's an example definition. Let star be defined on the set of real numbers by Cott. A star B equals A plus B plus A times B. This means to calculate a star B, you add the two numbers and then you add their product. You just follow the rule given. Let us try example 1. Simple calculation. Given a star B equals 2 times a plus B. Calculate 3 star 4 and 4 star 3. For the first part, 3 star 4. Here, letter A is 3 and letter B is 4. We substitute these values into the rule. The rule says 2 times a plus B. So we write 2 times 3 plus 4. 2 times 3 is 6. 6 plus 4 is 10. So 3 star 4 equals 10. Now for the second part, 4 star 3. Here, letter A is 4 and letter B is 3. Notice the order has changed. We substitute these values into the rule. 2 times a plus B, so we write 2 times 4 plus 3. 2 times 4 is 8. 8 plus 3 is 11. So 4 star 3 equals 11. Now look at the observation. 3 star 4 gave us 10. 4 star 3 gave us 11. 10 does not equal 11. This means the order matters. This operation is not commutative. We will talk more about that soon. Now let us move to section 3, properties of binary operations. There are 4 main properties we need to know. First is the closure property. A set S is closed under an operation star if for all letter A and letter B in S, The result, a star B, is also an S. For example, the set of even numbers is closed under addition. If you add an even number to an even number, you get an even number. The set of real numbers is closed under multiplication. If you multiply two real numbers, you get a real number. Second is the commutative property. An operation star is commutative if the order does not matter. This means a star B equals B star A for all letter A and letter B in the set. How do we test this? Step 1. Calculate a star B. Step 2. Calculate B star A. Step 3. Check if they are equal. If they are equal, it is commutative. If not, it is not commutative. Third is the associative property. An operation star is associative if the grouping does not matter. This means open bracket a star B, close bracket star, C equals a star, open bracket B star, C close bracket. How do we test this? Step 1. Calculate the left-hand side. That is open bracket a star B, close bracket star C. Step 2. Calculate the right-hand side. That is a star open bracket, B star C close bracket. Step 3. Check if the left-hand side equals the right-hand side. Fourth is the distributive property. An operation star is distributive over another operation. Usually addition if a star open bracket, B plus C close bracket equals open bracket. A star B close bracket plus open bracket. A star C close bracket. This is like the normal distributive law, from algebra. Now we come to a very important section, Section 4, identity element. Please pay close attention here because this is a frequent exam question. What is the identity element? It is denoted by the letter E. It is a special element in the set such that when it combines with any element A, it leaves unchanged. This means a star E equals A, and also E star A equals A. Think of it like this. In normal addition, the identity is 0 because 5 plus 0 equals 5. In normal multiplication, the identity is 1 because 5 times 1 equals 5. But in binary operations, the identity might be different. We have to calculate it. How do we find the identity element? Step 1. Write the definition of the operation with the letter E. So you write a star E equals the expression with A and E. Step 2. Equate it to A, because the result must be a step. 3. Solve for E. If you get a unique value for E, like E equals 0 or E equals 5, that is the identity. If E depends on DA or no solution exists, there is no identity element. Let us look at example 2. Find the identity element. Given a star, B equals a plus B minus 5 on the set of real numbers. Find the identity element E, step 1. Set a star E equals A. Using the rule, a star E becomes a plus E minus 5. So we write a plus E minus 5 equals A. Step 2. Solve for E. We want to isolate E. Subtract A from both sides. The A on the left cancels with the A on the right. We are left with E minus 5 equals 0. Add 5 to both sides. E equals 5. Step 3. Verify. This is optional but recommended. Check if E star A equals A. 5 star. A equals 5 plus A minus 5. 5 minus 5 is 0. So we are left with it works. The answer is the identity element is 5. Let us try example 3. Identity for a multiplication-like operation. Given a circle cross B equals a times B plus A plus B. Find E. Here, the symbol is a circle with a cross inside. Step 1. Set a circle cross E equals A. Using the rule, this becomes a times E plus a plus E equals A. Step 2. Solve for E. Subtracts back from both sides. We get a times E plus E equals 0. Now we need to factorize. Both terms have an E, so we write E times open bracket a plus 1 close bracket equals 0. For this to be true for all values of A, the letter E must be 0, because if E is 0, 0 times anything is 0. The answer is the identity element is 0. Now let us move to section 5, inverse element. This builds on what we just learned. What is the inverse element? If E is the identity element, The inverse of an element A, denoted as a to the power of -1, is the element that combines with A to give the identity E. This means a star, A inverse equals E, and also A inverse star, A equals E. How do we find the inverse element? Step 1, find the identity element, E first. You cannot find the inverse without knowing E. Step 2, let the inverse be X. Step 3, set up the equation. A star X equals E. Step 4, solve for X. Let us look at example 4. Find the inverse given a star B equals a plus B minus 5 with identity E equals 5. Find the inverse of 3. Step 1, identify knowns. A is 3, E is 5. Let the inverse be X. Step 2, set up the equation a star X equals E. So 3 star X equals 5. Step 3, apply the operation definition. The rule is a plus B minus 5. So 3 plus X minus 5 equals 5. Step 4, solve for X. 3 minus 5 is -2. So X minus 2 equals 5. Add 2 to both sides, X equals 7. The answer is the inverse of 3 is 7. Let us check. 3 star 7 equals 3 plus 7 minus 5. 10 minus 5 is 5, which is the identity, correct? Let us try example 5, general inverse formula. Given a circle cross, B equals a times B plus a plus B with identity E equals 0. Find the inverse of O. Step 1, set a circle cross A inverse equals E. So a times A inverse plus A inverse equals 0. Step 2, solve for A inverse. We need to group terms containing A inverse. A inverse times A plus A inverse times 1 plus A equals 0. Factor out A inverse. A inverse times open bracket, A plus 1 close bracket, plus A equals 0. Subtract A from both sides. A inverse times open bracket, A plus 1 close bracket equals -A. Divide by open bracket, a plus 1 close bracket, A inverse equals -A over a plus 1. The answer is the inverse of A is -A over a plus 1, provided A is not equal to -1. Now let us look at section 6. Solving equations with binary operations. Sometimes you are asked to solve for X in an equation involving the operation. Example 6, solve for X. Given a star B equals 2 times a plus B, solve for X if X star 4 equals 10. Step 1, apply the definition to the left-hand side. X star 4 becomes 2 times X plus 4. Step 2, equate to the right-hand side. 2 times X plus 4 equals 10. Step 3, solve for X. Subtract 4 from both sides. 2 times X equals 6. Divide by 2. X equals 3. Let us try example 7. Complex equation. Given a star B equals A plus B plus A times B. Solve for X if 2 star X equals 11. Step 1, expand left-hand side. 2 star X becomes 2 plus X plus 2 times X. Step 2, simplify. X plus 2 times X is 3 times X. So 2 plus 3 times X equals 11. Step 3, solve. Subtract 2 from both sides. 3 times X equals 9. Divide by 3. X equals 3. Now we will do a comprehensive worked example. This brings everything together. Question. A binary operation star is defined on the set of real numbers by a star B equals A plus B minus A times B. Part 1. Calculate 3 star 2. Part 2 is the operation commutative. Part 3. Find the identity element. Part 4. Find the inverse of 4. Let us solve part 1. Calculate 3 star 2. Using the rule, 3 plus 2 minus 3 times 2. 3 plus 2 is 5. 3 times 2 is 6. 5 minus 6 is -1. So 3 star 2 equals -1. Part 2, Test commutativity. We need to check if a star B equals B star A star B is a plus B minus a times B. B star A is B plus A minus B times A. Since normal addition is commutative, A plus B equals B plus A. Since normal multiplication is commutative, a times B equals B times A. Therefore, a star B equals B star A. Yes, it is commutative. Part 3. Find identity, letter E. Set A star E equals A. A plus E minus a times E equals A. Subtract A from both sides. Minus A times E equals 0. Factor out E quo. E times open bracket 1 minus a close bracket equals 0. For this to hold for all, E must be 0. So the identity element is 0. Part 4, find inverse of 4. Let the inverse be x. We know E is 0. Set 4 star x equals 0. Using the rule, 4 plus x minus 4 times x equals 0. 4 minus 3 times x equals 0. Add 3 times x to both sides. 4 equals 3 times x. Divide by 3, x equals 4 over 3. The answer is, the inverse of 4 is 4 over 3. Now, I want to warn you about common mistakes students make. Section 8, mistake number 1, confusing the operation with multiplication. Do not treat a star B as normal multiplication, A times B. Tip, always substitute into the given definition first. Mistake number 2, identity element confusion. Do not assume the identity is always 0 or 1. Dip, always calculate E using a star E equals A. It changes depending on the definition. Mistake number 3, inverse calculation. Do not forget to use the calculated identity, E, when finding the inverse. Tip, set a star x equals E, not necessarily 0, unless E is 0. Mistake number 4, order of operation. In non-commutative operations, do not calculate B star A instead of a star B. Order matters. Mistake number 5, algebraic errors. When solving for E or X, do not fail to factorize correctly. And for example, E minus a times E equals 0 becomes E times open bracket 1 minus a close bracket equals 0. Now, it is time for class evaluation. Section 9. I want you to pause the video and solve these in your notebook. Question 1. Given a star, B equals a squared plus B squared. Calculate 2 star 3. Question 2. Given x circle cross, y equals 2 times x plus y minus 3. Find the value of 5 circle cross 2. Question 3. For the operation a star B equals a plus B plus 2, find the identity element. Question 4. Using the operation in question 3, find the inverse of 5. Question 5 is the operation a star B equals a minus B commutative. Show working. Take your time. Write down your steps for your assignment. Section 10. Please do these at home. Question 1. A binary operation star is defined by a star B equals a times B minus A minus B. Part A, evaluate 4 star 2. Part B, find the identity element. Part C, find the inverse of 3. Question 2. Given a circle plus B equals 3 times a plus 2 times B. Solve for x if x circle plus 4 equals 20. Question 3. Test for associativity on the operation a star B equals a plus B over 2. Hint, check if open bracket a star B close bracket star C equals a star open bracket B star C close bracket. Question 4. If the identity element of a star B equals a plus B plus K is 2, find the value of K. Question 5. Given a star B equals a squared minus B squared, find the value of x such that x star 2 equals 5. Let us do a summary of what we learned today. Section 11. A binary operation is a rule combining two elements to produce a third. Commutative means order does not matter. Associative means grouping does not matter. The identity element E is found by solving A star E equals A. The inverse element is found by solving a star A inverse equals. For equations, substitute the definition into the equation and solve algebraically. I know this was a long lesson, but you have done amazingly well. Binary operations can be confusing at first because of the strange symbols. But you now know that the symbols are just rules. You just follow the rule. Remember, practice is the key. The more you practice finding the identity and the inverse, the faster you will become. If you enjoyed this video, please give it a like. It helps the channel grow. If you have not subscribed yet, please subscribe and turn on notifications. I post new lessons regularly. If you have any questions about this lesson, or if there is a specific problem you're stuck on, please comment down below. I try to answer as many as I can. And remember, for personal questions, my WhatsApp line is in the description box below. Do not hesitate to reach out. Thank you for watching. Keep practicing, stay confident, and I will see you in the next lesson. Goodbye for now.